Hi there folks, and welcome back to lesson 37 of the Dead Earth game development series, brought to you by Gary Simmons of the Game Institute. In this lesson we are going to focus on fully implementing Jill's crawling locomotion. Now if I select Zombie Jill's AI entity game object and call up the animator window, we are reminded that we do currently have a state on our base layer called crawling locomotion. And if I drill down into that by double clicking, you are reminded that this is a blend tree that contains a slow crawl animation that is triggered when speed is set to 1 and a fast crawling animation when speed is set to 2. However, you'll notice that we don't have any animations that handle the seeking left or right, much like we do with our generic locomotion. Just to remind you, when we are seeking left, this animation state is played that plays this animation that has a root rotation in it that takes care of rotating our game object. However, I do not have any turn left or turn right animations for a zombie in a crawling pose. So what I need to do is make sure that when the zombie needs to seek left or right, I'm just going to use whatever crawling animation is currently playing, such as this one, and I just want my alerted state to kind of rotate the zombie on the spot, much like we do in our pursuit, patrol and attack states when we're not using root rotation on our locomotion. However, that does not currently happen. To show you what I mean, let me select Jill's AI entity, scroll down to her AI zombie state machine script, and let me apply 95% lower body damage, which is way past the crawl threshold and will force her into a crawl from the start. Then I'm going to call up the scene view, and I'm going to pause the video and just wait until she gets to the very first waypoint, where she should stop and seek 180 degrees around to come back out of that room. Okay, so here she comes. She's just entered the room. She's just approaching a waypoint where she should stop and seek around about 180 degrees so that she heads towards the waypoint that's out of the room. But you'll notice that doesn't happen. Instead, she just goes on crawling into a wall in this particular case. And of course, if I leave it running for the moment and call up the animator for Zombie Jill, once again remembering to select her AI entity, this is because when Jill's in the crawling state, this locomotion is going to be playing. So even though our state machine is in the alerted state, which is going to be setting this seeking parameter to either 1 or -1, which in the case of generic animation would invoke one of these turn left or turn right animations, we don't have a turn left or turn right animation. So what we want the alerted state to do is, when we're in the crawling state, we want it to rotate the transform of the game object within the state itself, so we can carry on leaving her in this crawling state but have her rotate around. Now this is really an oversight from when we created the alerted state, because just to remind you, we have root motion configurators on our animation script. So in the case of our walk, jog and our sprint, which are being used when we're either in the patrol state, the pursuit state or the attack state, they have root motion configurators that have root rotation set to 0. And we know that if we select Zombie Jill and scroll down to her various states, we can see that in the pursuit state we have this variable called slurp speed, and we also have it in the attack state as well. And this slurp speed is what allows us to tell that state how it should rotate the game object if root rotation is not being used. But in the case of the normal turn left and turn right rotations, root rotation is being used, so our alerted state didn't have to worry about applying any rotation itself. Instead, right back in the AI state base class, we have this on animator updated function that's being called, and if we're using root position, we get that root position from the animation, divide it by delta time to calculate the nav agent's velocity and set that. And if we're using root rotation, well then we rotate the transform of the game object here by applying the root rotation that's fetched from the animation. And just to remind you, if I select, for example, our patrol state, remember the patrol state does have that slurp speed variable, and I scroll down to the update function, well you can see right here that there is a section of code that says if we're not using root rotation, well then that base class function isn't going to be called. So we need to rotate the object ourselves, and we do that by creating a new rotation quaternion and applying that to the rotation of our game object by performing a quaternion slurp, and of course using that slurp speed to control the speed of the rotation. Our pursuit state also has the same logic. However, our alerted state doesn't have this logic. If I bring up our alerted state and scroll down to the update function, you will find no such code that tries to rotate the game object under any circumstances. Instead, all these conditionals do is really just try to determine what the seeking variable in the parameter should be set to, either -1 or 1. So what we need to do to make seeking work in the alerted state when we're not using root rotation is we need to go up to where those serialized variables are listed, and we need to add a slurp speed variable. So I'm going to create a serialized field. It's going to be a float. I'm going to call it slurp speed, and I'm going to set it to 1 by default. I'm going to scroll down to the update function, and underneath all of the code where we're calculating whether the seek direction should be left or right, which remember sets the seeking parameter of the zombie state machine to either -1 or a +1, we just want to do a little conditional down the end that says if root rotation isn't being used, well then we need to rotate the transform of this game object ourselves from within this function. So I'm going to paste this line of code in, and then we'll talk about what it's doing. So as you can see, if we're not using root rotation, well then we need to apply the rotation ourselves. So we say zombie state machine.transform to get the transform of our zombie, and then we're going to use the transform class's rotate function. This takes a vector with x, y, and z describing the rotation we would like to apply around the x-axis, the y-axis, and the z-axis respectively. Now in this particular case, we just want to perform a y-axis rotation. So I create a new vector to send into the function with 0 rotations around the x-axis, 0 rotations around the z-axis, but around the y-axis we take that slurp speed that we set, which by default is just set to 1 degree, so we're going to want to ramp that up a little bit in the inspector, and we multiply that by our seeking property, which remember will be either -1 or +1. So that basically just means that whatever slurp speed is set to, which by the way is supposed to describe the number of degrees per second we wish it to rotate, I'm probably going to set it to something like 45 in a minute. By multiplying it by -1 we get a -45 degree rotation, a rotation to the left. If seeking is +1, then a 45 degree rotation to the right. And then of course we multiply that value by time.delta time so that we get a per frame update value with which to rotate it. So in fact I'm actually going to go up to the top of this function, and I'm going to change the default slurp speed to about 45 degrees per second by default. Now I think that is the only change we need to make in order to make our alerted state now properly rotate our zombie even when it's in the crawling state. So let's press play and see what happens to this bad boy. So I'm going to call up the scene view, and once again I'm going to pause the video until Zombie Jill gets somewhere much more interesting. Okay, here she comes. Oh, by the way, if you look at the alerted state in the inspector, you can now see we have that slurp speed set to 45 degrees. And of course the slurp speed is that same property that we've also seen in our patrol and pursuit states. So let me unselect Jill a minute so we can see what happens. So although she's not going to leave the crawling state, we should see her rotate, because now the alerted state itself is going to turn Jill around. There you go. How about that? We now really have a fully functioning locomotion for our crawling zombie. But there's way more to do than that. Now I want to show you another little problem that you may have noticed in the last video, but if not, I'll point it out now. So to demonstrate this, I'll fly over to where Zombie Jill is, and remember she's starting in a crawling state in the animator. Also remember that our zombie state machine starts in the idle state. So when we first press play, the zombie shouldn't really be going anywhere for about 5 to 10 seconds. But look what happens. And I'm going to clear the console window so we can just see when she's in the idle state, and also compare that with what's happening on the screen. So I'm going to press play, and you can see she's now entering the idle state. But look, she's still actually moving. And that's because we don't have an idle animation. So even when we're in the idle state, in the animator, Jill is in the crawling locomotion, which has root motion, and therefore she is being moved by the animation. But of course this is very dangerous because Jill doesn't have anywhere to go at that point. She hasn't been given a valid target. So were she to stay in the idle animation for, I don't know, a minute or 2 minutes, then you would probably just see her crawl straight into this stack of tires over here, or crawl into the wall. So we need to make sure that we have an idle animation as well, so that when she isn't supposed to be going anywhere, that animation plays. So what you need to do is you need to make sure that you download the zip file that accompanies this lesson, lesson 37, from the resources section of the Dead Earth channel. And I have downloaded that zip file. I have unzipped it. See this folder here, lesson 37 resources. And inside you'll see the scripts, of course, that we alter in today's lesson. But there's also an animations folder. And in there I have two FBX files that we wish to import. For now, we're just going to import the crawlidle.fbx. So let me call up Unity and just remind myself in the project view where we wish to copy this into. And I think we'll put this in the animations, the Game Institute folder, and the idle folder. Okay, so I'm going to make sure I have the idle folder selected in the project view, and then I'm going to drag my crawl idle FBX into that folder, and there'll be a small wait while Unity imports that animation. Then I'm going to select it and call up its import inspector so we can just see if it's imported correctly. Firstly, if you select the Animations tab, you might see this little warning here that says the clip range is outside the range of the source take. Don't worry about that, that's just a little mismatch with how it was exported from Dash Studio, the application that this animation was created in. So what we want to do is we just want to click that clamp range button and that will sort that out. We also need to apply those changes, and we also need to select the rig button and make sure that we tell Unity that this is an animation that is intended for a humanoid rig so that a humanoid avatar can be set up. So we're going to change animation type to humanoid. We're going to click apply, and hey, it's converted to a humanoid rig. Absolutely fine, no errors next to the configure button. So if we go back to the animation tab now, we should be able to see that currently this animation has one clip defined, which is called animation. Remember, the name of the actual clip, or clips if there's multiple clips, is what shows up in the project view under the actual FBX file when you open it out. So it's actually this animation that's called animation, this animation clip, that we're going to be dragging in to the animator. So I don't like calling it a generic name like that. So let's also rename this animation clip and call it crawling idle, like so. And we also need to tick the tick box that says loop time, as this is going to be a looping animation. And we're going to hit the apply button to apply those changes, and then we're going to press play. And as you can see, this animation just has the zombie just on the ground, moving its arms and legs around a little bit, just pondering what to do next with its life. And that's exactly what we want. So what we'll do now is we will select that crawling idle animation that we've just created. Now remember, it's not the actual FBX file you're dragging in. If you open up the FBX file, you'll see that the animation clip that we just renamed crawling idle is underneath that in the project view. That's the thing we want to drag and drop into the base layer, very important, of Zombie Jill's state machine. Obviously, it's not going to do anything at the moment because there is nothing transitioning to it. So we're going to have to change some of these transitions around. At the end of the last lesson, we added this transition here from any state into our crawling locomotion. And if I select this transition, you are reminded that it has 0 transition time. It has been configured such that if we are already in the crawling locomotion, then this transition will not be triggered again, because we saw that this caused the crawling locomotion to repeatedly keep triggering itself and kind of get stuck on frame 1. And the condition was simply that crawling equals true. Now this was fine because in the last lesson we only had one crawling state in our animator, but now we have 2 with idle, and you're going to see later on we're going to have a few more. We can no longer really do this logic. It was fine just for testing how our zombie reanimated from a ragdoll into a crawling locomotion, but there's obviously problems with this now. For example, the problem with just saying that we're always going to transition into this state if crawling equals true, even if we have can transition to self turned off, is that the minute we transition into the idle state, this transition is going to be triggered again to force us back into the crawling locomotion state. So that's clearly not going to work. And of course, the reason this transition was set up like this originally was just so that, first of all, we needed a way to transition into our crawling state when we first started the application, because by default, the upright idle animation is the default animation state. But it was more so that we could immediately transition into a crawling locomotion on the base layer when we were reanimating from a front down position as a ragdoll into a crawling locomotion. Because what we saw is that, let's say, for example, we shot the zombie when it was in a zombie jog state, then it gets reanimated. And what we saw is as we were reanimating, by the time we were supposed to fully transition back control to the animator, we saw the zombie almost seem like it was getting up onto its 2 feet before it went down into a crawling locomotion. And that was because it was taking too much time for our zombie jog here to transition down into idle and then from idle into the crawling locomotion. Remember, this was all happening behind the scenes on the base layer, but we still needed to make sure that the transition into the crawling state was immediate, especially when reanimating from a ragdoll. So what we're going to do instead is we are going to change this transition, and we're going to say it's only going to be triggered if crawling is true and the reanimate from front trigger has been set. So this transition now will only ever happen when we are coming out of a ragdoll, which means we're going to need a more regular way of putting the zombie into idle at startup. So we'll create a transition from zombie idle into crawling idle, and we'll turn off has exit time, and the condition will simply be if crawling equals true. So obviously when the game starts, our zombie will be in this default state, which is the upright idle, but we want it to immediately transition into the crawling idle if the crawling boolean is set. So we also want to set the transition time down to 0, so this happens immediately. Okay, so if I press play now, then what we should see is our zombie will immediately transition into crawling idle. And there she is doing her thing in the idle state. Now, we haven't put any root motion configurators or anything on this yet, so what you're going to see in a minute is, because she's stuck in the idle animation, but we're not using root position, the nav agent has now taken control of our zombie. So we need to sort that out by adding a root motion configurator to our crawling idle state, and we'll set root position to 1 and also root rotation to 1 as well. And you should see now that irrespective of what state we put her in our zombie state machine, as she is now locked in the zombie idle state, she is not going to be going anywhere even when she's been put into the patrol state, which she has now. And that's because she cannot leave the crawling idle animation just through state change alone. However, you'll notice that we still have the any state transition to the crawling locomotion. So what that basically means is if I were to shoot zombie Jill now and make her ragdoll, then when she comes out of the ragdoll, this transition will be invoked and she will actually then be in a crawling state. So let's just check that works. Call up the game view. Let's just shoot her in the head. And we should see her now come out into a crawling state, and then she'll actually be in a crawling state. So we can see that the crawling state and the seeking state all works. Oh, she's coming at me fast now. So what we need to do is connect the idle animation to the crawling locomotion. And you might think as well that maybe this any state transition should go into the idle state. But actually I didn't like it as much doing that, because when the zombie comes out of a ragdoll, it goes into an idle state, and then because it's in the alerted state in the zombie state machine, it gets forced straight back into a crawling state anyway. So I just say when we come out of ragdoll, I want it to go straight into the crawling locomotion. So what we'll do first of all, although this isn't going to work very well, I want to show you the steps that I went through, is we'll set up our crawling locomotion much like we set up our locomotion here, where we have the walk, the jog and the sprint animations, and they transition back into the idle when the speed drops to 0. Now the difference here of course is that if we go into an alerted state from say a patrol state, speed is set to 0, we drop back into idle, and then one of the seeking parameters is set, which sees us transition into one of these turn left or turn right animations. Now we haven't got the ability to do that because we don't have turn left and turn right animations for our crawling zombie. So what we need to do is say that we're going to transition into the crawling locomotion state if speed is larger than 0, and we're only going to go back into the idle state if speed is 0 again, and if we are not seeking, because remember in the crawling state, if we are seeking, we wish the zombie to stay crawling, because it would look really weird if we have her being rotated left or right in an idle state. That would just look like the nav agent is just rotating her on the spot. So let's create the transition from idle to the crawling locomotion, and that won't have has exit time ticked. It will be a simple condition of if speed is greater than 0. The transition back into idle needs to be slightly more complex. It needs to once again have has exit time disabled, and we need to say if speed is less than 0.1, in other words if it's 0, and also if seeking is 0 as well. So of course this is important, because if she is seeking left or right in the alerted state, we don't want her to stop, drop back into idle, only to drop back into the crawling locomotion state again to start turning on the spot. But you'll see this actually has some problems. So let's see what happens. And what I'm going to do, well actually I'll just check that it's definitely working. So we should see her there for a few seconds, and then she starts crawling. She's now in a crawling locomotion state. And then we'll go over and we'll see what happens when she gets to her first waypoint, okay? I think what I'm going to do for this is I think I'm going to move the scene view down the bottom so we can also see what the animator is doing at the same time. I'm just going to pause the video so we're not waiting for her to get around here. Okay, so here she comes. Okay, so she should never drop back into the idle state, because as soon as she hits a waypoint, she's going to be in the alerted state trying to acquire the target for the next waypoint. But you'll see that doesn't happen. She actually, there you go, she's dropped back into the idle state, which is not at all what we want. And in fact, it's even worse than that, because our idle state, we said, uses root rotation, which means that our idle state doesn't rotate the zombie, which means she's forever stuck there. So what we could do is we could say, well, we're not going to use root rotation, and we'll see what happens then. She'll no longer be stuck at that location, because our zombie state machine will actually rotate the zombie around in the state, but you'll still see that she drops back to the idle state, even though we are explicitly stating here that only go back into idle from a crawling locomotion if speed is 0 and if we are not seeking. So why on earth is she dropping back into the crawling idle state when she should be seeking? Well, I'm going to pause it again. I'm going to wait for her to get into this room, and then we'll see what's happening again. So here she comes, and I think what you're going to see now is she will rotate, because we have disabled root rotation, which was locking her orientation in place in the idle state, but you'll still see her drop back into the idle state when she goes into the alerted state. Just for a moment. There you go. And it doesn't look right, does it? And now you're seeing her rotating on the spot before she starts crawling off again. So that is, of course, not at all what we want. We don't want her dropping back into that idle state. And the reason she's dropping back into the idle state, even though we're saying don't drop back unless speed is 0 and seeking is 0, and of course seeking shouldn't be 0 at this point because she's acquiring a new target. But of course what this is a timing issue. In our zombie state machine, when she is patrolling to her waypoint, as she exits the patrol state and enters the alerted state to acquire her new target, her speed is set to 0. But at that point, an update hasn't happened that has set her seeking to either -1 or +1. Therefore, for a moment, and all we need is one moment for this transition to be triggered, speed is 0 at the start of the alerted state, and seeking has not yet been set to 1 or -1. And that's what's causing this idle animation to trigger. And of course, the reason why we saw her just stay in the idle state for a period of time while she was rotating on the spot is because after the crawling idle animation was invoked, well, we've got a transition here back into the crawling locomotion only when speed is greater than 0. But of course, when she is in the alerted state in our zombie state machine, and she is in the crawling state in our animator, the speed is still 0 while she's seeking left and right on the spot. So this transition isn't being triggered, so she just stays in idle while she is rotated on the spot. And then when she gets past that angle threshold and the speed starts to be incremented again as she heads towards the next waypoint, we saw a transition back into the crawling locomotion. One of the ways that we can almost fix this is if we create another transition from idle into the locomotive state again. And whereas the first transition is activated when speed is greater than 0, we can set the condition here. I'll also set off has exit time, and I'll set this condition so that it's activated when seeking doesn't equal 0. So what will happen in this particular case is when Zombie Jill reaches her waypoint and she's in the crawling locomotion state, we will be transitioned on the zombie state machine side into the alerted state, which we know will temporarily drop the speed to 0 before the seeking has been set to either 1 or -1. So that's going to activate this transition. It's going to send her into the idle state for just a moment, but then in the very next frame update within our alerted state, that seeking parameter in our animator is going to be set to either 1 or -1, and then that's going to trigger this transition back into the locomotive state. So what we'll see is the zombie reach its waypoint, and we'll see it transition just for a very brief period into the idle state. But then as she starts to turn, the next update, it will already be transitioning into the crawling state again. It's still not what I want, but let's just press play and check we're definitely understanding how all this is working. And once again, I'm going to wait in that room by the first waypoint, and I'm going to pause the video until she reaches the entrance to the room. Okay, so here she comes, and remember to watch the animator as well. So we should see her reach that waypoint, we should see it transition into the idle state for a little bit, and then immediately transition back out into the crawling locomotion when seeking gets set to a non-zero value. But if you look at her in the scene view, you know, it still doesn't look good, does it? I don't like the fact that she goes into an idle state for just a little bit of time. And I'm just going to run that again, just so you can definitely see what's happening. This time, don't worry about what the animator's doing. Just watch Zombie Jill. And, you know, you'll understand, I think, why I don't particularly like her going to idle for just a few moments. Now, it's worth mentioning that this is exactly what happens with our generic locomotion. When she's walking, jogging, or sprinting, she goes back into the idle state and then transitions into one of those turn left or turn right states. So that's pretty much what's happening here. We're transitioning back into the idle state and then back once again into the crawling state. But for whatever reason, I don't think it looks good with the idle crawling animation. So I want to stop that happening, and that's what we're going to do next. But like I said, let's just wait for her to come into the room so we can just see what we're dealing with one last time. So here she comes again, and like I said, this time don't worry about what the animator's doing in the top window, just look at Zombie Jill. So she's crawling. I want her to just carry on crawling and rotate on this spot, but you'll see when she reaches the waypoint, you see her just kind of stop in the idle state for a little bit before she starts crawling. There you go, now she's in idle, and then she starts crawling again. And to me, that although that looked fine with our upright two-legged animations, it doesn't look right with the crawling animation. So I need to be able to have the power in my animation system so that I can choose to transition based on other things other than, for example, just what speed and seeking is. So what I really want to say is I only ever want to transition into the crawling idle state in the animator if we are actually in the idle state in our zombie state machine. But at the moment, of course, our animator has no way of knowing what state our zombie state machine is in. They're just two separate state machines that are not linked. So what we'll do is we'll create a new parameter that sends into our animator the state that our zombie state machine is currently in, and that allows us to then have the ability and flexibility, such as in this case, to transition based on what the underlying zombie state machine code is doing. So I'll be honest, I got pretty excited when I thought about adding this feature to our system. I was out walking my dog and I thought what I could do is I could create a string parameter in my animator so that we would be able to see when we're creating our transitions. We could say things like if state equals idle or if state equals alerted. Because remember, if I go back to our AI state machine base class, we always maintain what our current state type is. And it's one of the AI state type enumeration. So it'd be really cool if in the update function I could simply just take the current state type, which is here, and send that into our animator so that we can visually see what the current state type is and transition based on it. Perfect. However, what I totally forgot when I came up with this system, and it's a crying shame, the animator in Unity, at least in this version of Unity that I'm using, does not support string parameters. So we either create a float, an int, a bool, or a trigger. So what we're going to have to do, which I have to admit is much less elegant, is we're going to have to create this as an integer, which kind of upsets me. So I'm going to call this new integer parameter state. Okay, and then what we're going to need to do in our zombie state machine, in our update function where we update all of the animator parameters, we're going to add another one where we're going to say animator set integer, and we're going to have to create a hash for this so we can set it efficiently. So I'll just call this state hash. This is going to go red for the moment because we haven't created the state hash variable yet. And then what we'll send in is we will send in the current state type, which, although it's enumeration, of course what's really cool about this enumeration is we can simply cast it to an integer. So now if we go back up to the top and create underneath where we create all of our hashes, this new state hash, I'll create a private int, state hash, and it equals of course animator, and we call the static string to hash function, and we pass in the name of that new parameter we've just added to our animator called state. And that's pretty much all we need to do to send in the values of our state type enumeration into the animator. And if I call up Unity once again and press play, just don't worry about what the zombie is doing, just watch the state parameter. It's currently 1, which is the idle state, and then when it goes into the patrol state, I think that's the third one in the enumeration, so it should go to 3. There you go. So we now know as long as we have the source code available, which is why it's so unelegant, and we can look at the AI state type enumeration. We now can generate transitions based on the integer values of this enumeration. So we know that if it's 0, then it's in the none state. If it's 1, the idle state. 2, the alerted state. 3, the patrol state. 4, the attack state, and so on. Like I said, it would be really nice if instead of using an integer basis for this, we could actually send these in as strings, but we are not allowed to have string parameters in the animator at the moment. So there's nothing we can do about that, but it does mean that if you are creating transitions in the animator based on the state type of our zombie state machine, you might have to just refer back to the AI state machine base class at the top of the file where we define this enumeration, so you can see what the 0 based index is of the particular state that you're basing a transition around. So what we can do now is I'm going to delete these two transitions completely from the locomotion state into the idle state, and we're just going to say we are going to transition from idle into the crawling locomotion, and I'll turn off the has exit time, whenever state doesn't equal 1. In other words, whenever we are not in the idle state. Remember, if I go back to the source code, 0 is none, 1 is idle. So when state doesn't equal 1, we transition into locomotion, and of course, we create another transition from the crawling locomotion state into the crawling idle state, once again turning off has exit time, and the condition is of course the reverse, when state does equal 1. So now this transition is based purely on what our actual code is doing, what our AI zombie state machine is doing, and what state it's currently in. So this is great because we don't have to go back and alter all of these transitions because we're quite happy with those working with speed and with the seeking variable. But it just means we now have the flexibility to also access what the underlying zombie state machine is doing and set up transitions based on that. And if I press play now, unless I'm gravely mistaken, what we should see is when the zombie enters the room, it doesn't drop back into the idle state at all. It stays in a crawling state. And in fact, it will only ever go into the crawling idle state if our underlying zombie state machine is ever forcefully set into the idle state itself. Okay, so here she comes, and she should just stay in that crawling locomotion and rotate on the spot, which is much nicer and much more what we want. Fingers crossed. Come on, Gary, don't make a fool of yourself here. There you go, that looks better, doesn't it? So even though speed dropped to 0 and seeking was 0 for a short period of time, it didn't drop into the idle state because our underlying AI zombie state machine was not in the idle state. So that gives us a whole range of powers now going forward where we can not just transition animations based on the physical characteristics of how the zombie is moving, such as speed, whether it's seeking or feeding or crawling. We can also do it based on the physical state change that's happening in the underlying zombie state machine. Okay, so that's one more little issue we've resolved, but there are plenty more to visit in this lesson. The next thing I want to talk about is this crawling locomotion state that we added to the base layer many lessons ago when we were actually using blend trees for all of our locomotion animations. You may remember that when we first created our generic locomotion, we had the idle, the walk, the jog and the sprint in a 1D blend tree as well, much like our crawling animations are currently in. In the end, we decided against them because we had to beg, steal and borrow our animations from various different sources around the internet. They weren't really designed as a single set that worked very well in a blend tree. So here we have our blend tree that has this slow crawl animation and it has this fast crawl animation. Okay, now when we're using either just the zombie slow crawl or we're just using the fast crawl, in other words when speed is either 1 or 2, these animations look fine. But of course we're not really using our speed parameter now in the conventional way. You see, the more conventional way might be to, for example, have our nav agent control the speed and movement of our entity. And every frame we would get the current velocity of our nav agent. We would send the speed in as a parameter into our animator, and then that speed would be used as the variable in the blend tree to choose the correct blend of animations so that it represents as closely as possible the speed that the nav agent is actually going. We decided against that because if I select the blend tree, and let's just say for example that we were using real speeds here between let's say 1 miles per hour and 2 miles per hour, but our nav agent was only going 1.5 miles per hour. Look, our animations don't really look right when they are using a constant blend of more than one. Now if you've got animations that do, that's fine, but we don't. So what we decided to do And I should say that we noticed many lessons ago that this was much more obvious when we had the walk, jog and sprint in a blend tree, which is why we decided to, in the end, break them out into separate states and just configure transitions between them so we get a smooth blend between them, but we're never in a situation where the zombie is being moved around using a constant blend of, say, 50% walk and 50% jog. And we want to do the same thing with our crawling locomotion. Of course, the other problem is because we decided to do it that way, and we decided to use the speed parameter not to contain the actual speed of the character, but to contain kind of like our own speed mapping system, where a speed of 1 means it's a walk, a speed of 2 means it's a jog, a speed of 3 means it's a sprint. So let's say, for example, okay, that we set our patrol state for our crawling zombie to have a speed of 1. So it's going to be crawling around like that, no problem. But then let's say that we transition our zombie state machine from the patrol state into the pursuit state, and we set the speed of the pursuit state to 2, so it uses the fast crawl. Well, that transition on the zombie state machine side from the patrol state into the pursuit state is instant. So what we see is the speed instantly change from 1 to 2 like that. You can see, if you look at the animation in the bottom right preview window, we get this very hard instant snap from one animation pose to the other. So to show you this, it's pretty visible. If you haven't seen it before when I've been running the game, let's press play now and let's see this in action, where you can see that the minute we transition our zombie from a patrol state to a pursuit state, we see a very, very hard snap of the zombie from the slow crawl to the fast crawl. So are you ready? Are you watching? I'm going to move around the side of her, and when she sees me, look at the massive jolt we see happen. There you go. Did you see that? Okay, I'm going to just press play again so you get to see it again. Okay, here I am. I'm going to let her crawl first so she's already in the slow crawling state. As I move around in front of her, she just snaps really abruptly. It's just not a blend at all. So that's why the blend tree is really not going to work for us. So what we want to do actually is we want to delete this crawling locomotion completely, and we want to have these two separate animations on our base layer, so that we can set up manual transitions between them. So let me just have a look at what animations are being used here. The slow crawl is in the Game Institute locomotion folder, and it's called Zombie Crawl 1, and underneath that we have Zombie Crawl Fast. So I'm going to undo the work that we just did, and we're going to delete that state, and that's going to suck because we've just lost all those transitions we set up. But hey, this is what development is like. And I'm going to go into the locomotion folder of my Game Institute folder, and I'm going to copy over Zombie Crawl 1 and Zombie Crawl Fast, like so. And then I'm going to add root motion configurators to those. And we're going to set the root motion configuration for both those to root position, but not root rotation, just like we do with our standard locomotion states. And what we'll do is we'll create, first of all, that transition from any state to the zombie crawl, which we said needs two conditions. The first one is when reanimate from front has been triggered, and the other one is when crawling is set to true. So that just makes sure that when our zombie has been ragdolled and it's a crawling zombie, it will, as it gets up and blends from the ragdoll, it will immediately transition into the slow crawl. Then what we will do is we'll create a transition from crawling idle to zombie crawl. This transition is going to be pretty simple too. It's not going to have a has exit time, but what it is going to do if state is not equal to 1. In other words, if we're not in the idle state, then we must at least be in the zombie crawl slow state. And I'm going to do a transition back. Really, I'm just replacing the transitions that we just deleted, but this time instead of going from the blend tree, I'm just going from zombie crawl 1. So with the transition from the slow crawl back into the idle, no has exit time if state equals 1, which remember is the value of our idle member in our enumeration. What we're going to do now is we're going to create transitions from the slow crawl into the fast crawl, and back from the fast crawl into the slow crawl. And while I'm here, I'm going to rename that Zombie Crawl 1 to Zombie Crawl Slow, like so. And now I'm going to remember to press enter. I keep doing this, and then it doesn't update in the actual animator. Okay, so we know that when our speed is 1, we wish it to use the standard slow crawl. But when our speed is greater than 1, we wish it to use the fast crawl. Now, in the case of our generic animations, we actually have 3 speed tiers. 1 is walk, 2 is jog, 3 is sprint. We don't really have that for our crawling animation. We just have slow and fast. So If the speed is 1, we use slow. If it's greater than 1, so if it's 2 or 3, we use fast. So for that, I will select the transition from the slow crawl into the fast crawl. I will set has exit time off, and I will create a transition that said if speed is greater than 1. And then I will create a transition back from the fast crawl into the slow crawl, once again remembering to turn off has exit time with the condition that says if speed is less than 2. This means we now have power to really control the speed of the blend. So what I'm going to do is I'm going to turn off fixed duration. So the 0.25 is actually describing 25% of the entire length of the animation, which is about 7 seconds. So it's actually going to be about a 3-second blend. I'm probably going to do the same. No, I'm going to leave the transition back just at its default quarter of a second. So if I press play now, let's see how she smoothly moves, if I've done everything right here, from a slow crawl into a fast crawl when she spots me. Let me just wait for her to start crawling. Okay, so watch her. She sees me, and now she's starting to come at me, and there was no jolt at all. Perfect. Okay, let's see that again. Just so you know, I'm not lying. Going to maximize the window. Going to wait for her to start crawling. Come on, Jill, get a move on. Okay, and watch her. When I go in front of her, it's a really slow crawl. She sees me, and then she starts to gather speed. Love it. Okay, so that's another problem resolved. We've got rid of that blend tree. We've now got control over the blend, and by removing the blend tree, we've got a system that works much better with our bespoke speed system, and we also have total control over the blends without worrying that we're ever going to set the speed to a value that might have our zombie using a constant blend of more than one animation, because we've just seen that doesn't work well together. But like I said, blend trees are really cool when used with the right animation sets. So before we carry on and start to add the attack animations for our zombie when it's in the crawling state, I do have a few other things that I need to address, and the first one actually is a bit embarrassing because I didn't notice this until it was pointed out to me on the Game Institute forum. And that is, you will remember many lessons ago when we were creating our zombie attack system, we added damage triggers to our zombie's hands and to our zombie's mouth. Now if I just, where's my zombie gone? There it is. Okay, so if I select Jill now, look, they are all gone. In fact, if I open up a hierarchy and scroll down to a left hand, you can see that we still have the AI damage trigger script on that game object, and it's still assigned to the AI trigger layer. The same is also true of her right hand. That sphere trigger that we used to have on those hands is completely gone. If I select the mouth trigger game object, you can see we have the AI damage trigger script on it, and it's assigned to the correct layer, but the triggers themselves have been removed. So it turns out this happened when we used the ragdoll wizard to create all of the colliders and rigid bodies for Jill's ragdoll. Now it's a bit embarrassing because that was actually many lessons ago and I hadn't even noticed. And you'll notice that if I press play now, actually what I'll do is just temporarily I will select Zombie Jill, I will open up a zombie state machine, and I will put her lower body damage back down to 0 so she's not forced into a crawling state. And you'll notice that if I go up to Jill and she attacks me, come on Jill, come get me. There she comes. She's coming. When she attacks me, look, absolutely no damage, and that cool blood lens effect that we did on our camera is not even being used anymore because with those triggers removed, Zombie Jill is completely unable to do any damage to us. So we have to add them. I can only assume that the Ragdoll Wizard has this kind of pre-pass over the skeletal hierarchy where it says just before I add all of those colliders, I'm going to remove any that are already there, and I hadn't even noticed that. So let's add them now. I'm going to select the left hand, I'm going to add a sphere collider, and I'm going to make it a trigger. Remember, that's really, really important. I think we set the radius down to something like 0.18, and we also had to offset it along its y-axis, which is this green axis here, just a little bit, something like 0.06. Yeah, something like that. So the center of the trigger is right in the center of her hand. So what we'll do is, while that is fresh in our memory, we will tap over to the right hand, and we will add a sphere collider there too, with the same parameters. 0.18 radius and offset along the y-axis by about 0.06, And remembering, of course, to set this as a trigger. That's really important. If you leave this as colliders, first of all, it won't generate the trigger messages that apply the damage to the player. Furthermore, the physics system will try and resolve that collision, so when the zombie hits you with the big sphere collider, it will actually knock our player back. And then we have the mouth trigger, which I have to be honest is not so cemented in my memory, so we'll have to just come up with something similar to what we had before. Now, our mouth trigger had a capsule collider on it, didn't it? So I'll type cap. I'll choose capsule collider, there you go, and I'll bring the radius in a little bit so we can see its orientation. You can see its orientation is wrong at the moment. It's using y-axis alignment. We had to set it to z-axis alignment, so it was pointing out the front of the zombie's mouth. And I think we had the radius at 0.08. It didn't need to be a very thick capsule, but the height's wrong at the moment. I think that's something like 0.45. And we need to offset it along the z-axis, don't we? By, I don't know, 0.24. That looks about right. We needed it to stick out quite a long way, didn't we? Oh, and of course I have to remember that that capsule collider also has to be a trigger. So if I press play now, I'll maximize it for maximum effect. When Jill comes and attacks us, we should see some of that blood on our screen again. Hello Jill, come and do your thing. There you go. She's attacking us and we're getting blood on the screen again. Perfect. Bit embarrassing that. I didn't even know it wasn't working. I hadn't even noticed. Dear me. The other thing I want to draw your attention to was actually a mistake that I made at the end of the last lesson. Now, this isn't important because what I did still works, but I said something which wasn't strictly true and was unnecessary. So if I select the cinematic layer, you remember in the last lesson we added all of those reanimation animations. And I said that we needed to add a cinematic enabler to every one of those on the cinematic layer. And we needed to make sure that it set the cinematic boolean in our state machine as the state was entered. However, this isn't true. We actually don't need cinematic enablers on any of these. It doesn't hurt that we do, but we're just being redundant because you will remember that our empty state, the default state for this layer, has a cinematic enabler on it, which sets the isCinematic boolean in the zombie state machine to true whenever we exit this state on the cinematic layer. So we don't need to put cinematic enablers on anything else on this layer, because whenever one of those animations is triggered, it's going to mean that the onExit state function of the cinematic enabler on the empty state has been called and set that boolean to true. So I'm just going to remove all of those cinematic enablers from all of the other animation states on this layer. Once again, a little bit embarrassing, but I tell you, sometimes there's quite a bit of time between me recording these videos because I'm working on other projects as well. So sometimes when I come back, I can forget that I've done things like that, where I've actually put a kind of inverse enabler on the empty state. Okay, so I'm going to select the base layer and I'm going to select Jill's AI entity, and I'm going to once again put lower body damage back up to 95 so that we force her to be in a crawling state whenever we start. Because what we have to do now, folks, is bring in some attack animations that can be used by Zombie Jill when she is in the crawling state. Because at the moment, if I press play, when she crawls up to me, she can't actually do anything to me. Look, she's just going to crawl up and she's just going to keep crawling into me like that. Because all of the attack animations that we've got are on the attack layer, and furthermore, because these are animations that should only be played when she's in a non-crawling state, each one of these has its condition set to if crawling is false. So none of these attack animations will ever be triggered on the attack layer when we are in a crawling state. So we don't currently have any attack animations for when our zombie's in a crawling state, but never fear, because in the zip file that I hope you've already downloaded that contained that idle animation that we imported earlier on, there is also in that animations folder another FBX file called crawlattack.fbx, and this FBX file actually contains two animations. It contains a swiping animation with the hand in a crawling position and also a biting animation so that our crawling zombies can also bite you. So we need to import that into our project, much like we did with our idle crawl animation. So I'm going to call up the project window, and I think I'm going to copy this into our Dead Earth Animations Game Institute attack folder. Makes sense, right? So I'm going to drag that attack animation in there, wait a moment for Unity to import the file, and then what we'll do is with the inspector selected, we will select our crawl attack FBX file, and we're going to select the rig button first of all in the import inspector and make sure that we set this to be a humanoid rig under the animation type drop down. Once we've made that selection, we click apply and just make sure that we get a little tick box next to the configure button that just assures us that this was able to be recognized as a humanoid rig without any problems by Unity. So now I'm going to select the animations button so that we can see what is in our file. And if you see this little warning here that says the clip range is outside the range of the source take, don't worry, just hit the clamp range button and that will get rid of the few stray frames that are on the end. Not sure why that happens, but it doesn't present any problems. Probably something to do with the export settings within Dash Studio. So if I just open up the preview window, you can see at the moment there is only one animation clip defined in this FBX file, and it's just all of the keyframes in the file. So it contains this feeding animation and this swiping animation. Okay, so we're going to need to split those apart into two separate animations so that we can add them as two different animation states in the animator. So we currently have this one animation clip which contains all of the animations in our clip list. Let's not mess about with that. Let's leave that there. It's quite handy having a clip like this defined so that we can very easily look through all of the animations contained within the FBX file. But what I am going to do is I'm going to rename this clip and I'm going to call it all anims. Then I'm going to press return, very important. You can see now the name of this animation clip has changed to all anims. And then I'm going to scroll down and click the apply button so that those changes are committed. So now what I need to do is I need to separate out the different parts. So I'm going to work first of all on the biting animation. So I'm going to go up to my clip list and I'm going to click the plus sign to create a new animation. And this is going to start off by giving me a clip with all of the animations defined in the file, which means because we have that weird kind of import error, we are going to get that clip ranges outside the range of the source take error again. Don't worry about it. Just click the clamp range button and it will go away, and it will then allow us to sort of seek through the file using these markers to just mark out the bit of the animation we want. Now if you look at the feeding section of our animation, you can see that it starts off with the arm coming up to the mouth, almost like the zombie is trying to grab your leg, and then it goes into this second or two of biting you. Now the problem is we don't really want to chisel this out as a separate animation, right, and have the arm coming up like that, because our zombie can be feeding for an undefined length of time. Once the zombie latches onto you, it can literally just keep biting you until you step away or shake it off. So it's going to make it impossible to loop if we keep having this arm coming up, because every time the animation loops we're going to see this. So we actually want to edit that bit out and throw it away. And it's not a big deal, because when our attack animation is played, we're going to be blending from a crawling position anyway, where the zombie's hand is going to be on the floor. So naturally, as part of the blending, we're going to see the hand come up kind of like that anyway. So I think I'm going to start it about there, and then I'm going to pull the end marker back to where I think this animation stops. Probably, yeah, about there. And then what I'm going to do is I need to make this loop, because if I press play at the moment, if we imagine this is playing indefinitely, we're getting that little jolt as the animation wraps around. So we need to click loop time, and then we're going to ask Unity to perform some blending between the keyframes at the end of the file, or the end of the clip, and the preframes at the beginning of the clip by clicking that loop pose button, and that's going to do that. So as you can see, that's looking pretty cool. We have ourselves a looping animation. I think what I'm going to do as well, just looking at the animation file, I can kind of see that there's a little bit of Y movement, which may cause the origin of our game object to sink beneath the floor. So just to be on the safe side, I'm going to bake any of the root position along the Y-axis into the pose itself. Remember, this is what we did to stop the zombie sinking through the floor when it was coming out of the ragdoll. And you can see now we don't get that ghosting on the grid. It's firmly got its center point on the actual ground plane. So I've hit apply, but I've done that prematurely because I haven't renamed it yet. So I need to rename this new clip that we've defined and call it biting. Oh, and remembering to press enter. I always forget to do that, and then the change is thrown away, and click apply. So there's our biting animation. So what we need to do now is create another animation clip for when the zombie wants to hit you or swipe at you with its hand. And we're going to create two versions of this so we can mirror it and have a left hand and a right hand attack. So once again, I'm going to go up to the clip list. I'm going to press the plus button, and then I'm going to hit that clamp range button to get rid of that little import error. And then I'm going to rename this animation clip. Actually, I'm not going to rename it because I don't know what hand it's swiping with. So it's a left hand swipe. So we'll call this left swipe, like so. and I just need to kind of come from about that position there. Remember, we're going to be coming from the animation when it's crawling, so its hand is going to be on the floor, so it doesn't matter too much that there's not a clear divide between these two animations. We'll make the arm come up to about there and then start the swipe. So that is start frame 63, just in case you're following along exactly, and we'll come down to about almost to the end of that there. I'm just trying to think in my mind about how, when it's transitioning back into the crawling locomotion, how it's going to look. Yeah, I think we can take that end marker to about 96. Now this doesn't need to loop, because unlike the feeding or the biting animation, it's not repeatedly being looped around. When this animation is played, it's going to be a one-off where it's going to blend from the crawling locomotion, play that swipe, and then as it comes out of that swipe, it's just going to blend back into our crawling locomotion again. Our zombie state machine may then decide to then trigger an attack again, but it might not be this attack, it might be the mirror of this attack, a right-hand swipe. So once again, I think what I'm probably going to do is, just because I'm seeing that ghosting on the grid, I think I am going to bake the vertical movement of root motion into the pose to make it a bit more stable, like that. And then now I have that, what I really want to do is I want to duplicate that. I don't think I can I? So wait, do I have to create it again? Yes, I do. So I've added a new clip, but I just need to make sure that I use the same start and end keyframes, which is 63 and 96. Once again, I'm going to clamp the range on this new clip. I'm going to call it right swipe, and I'm going to set the start frame to 63, just like the left swipe, the end frame to 96, once again just like the right swipe, and I'm going to tick that bake into pose for the root position along the y-axis. Click apply, and we should now, oh, I didn't mirror it, did I? So then I have to click the mirror tick box, click apply, and now what I have is a right swiping animation as well. And like I said, don't worry about the fact that it's not looping. This animation does not need to loop. So now we've set up those three animation clips that we want, left swipe, right swipe, and biting. If we open up the crawl attack file in our project view now, we can see that it has those animations defined, and we can drag those now into our animator. So I know what you're thinking. You're thinking, well, these need to exist on our attack layer. Well, you're going to find out that actually I'm going to end up adding these to the base layer, but I'm going to follow through the logic that you're probably thinking, because it's what I thought when I brought in these animations. I wanted all of my attacks to be on the attack layer. So let's follow through that logic now and see what happens when I do that. Okay, so just to recap, on our attack layer in our animator, we currently have all of these various attack animations that are used by our zombie when it's not in a crawling state. And you can see that if I select any of these transitions from empty state into the various attack states, they all have the condition crawling equals false. Okay, so none of these are going to ever be activated when we're in a crawling state. And of course, what we're going to do is we're going to add those crawling attack animations we've just set up to this layer and set up transitions so that we now have attacks that can be played when we are in a crawling state. But just to remind you how the attack system works, in the parameter list of our animator, we have this integer parameter called attack, which is set to 0 by default when no attack is happening. We also have an attack state in our zombie state machine, which when activated and it decides to launch an attack, we'll set this value to a random number between 1 and 100. We can use this attack value in our attack layer to set up the probabilities of different attacks being invoked. So for example, we can see that if the attack is between 1 and 20, in other words 20% probability, then this attack 1 is activated. And you can see it says in its condition list, if attack is greater than 0 and attack is smaller than 21 and we're not crawling, then this attack is launched. The second attack though is a slightly more rare attack with a lesser probability. You can see here we only give it about a 15% probability. This will only be selected if that attack integer that has been generated randomly by our attack zombie state is set between 21 and 35. So for now, what I'm going to do is I'm going to ignore the crawling biting attack, and I'm just going to bring in the left attack and the right attack for our crawling zombie, and we're going to hook these up. So of course the FBX file that we imported is in the Animations, Game Institute and Attack folder. If I open up the crawl attack FBX file, you can see we have the left swipe animation clip and the right swipe animation clip. And what we'll do for now is we'll just set the probabilities of each of these to basically a 50% chance of each one being selected. So I'm going to create a transition from empty state to left swipe, a transition from empty state to right swipe, and the left swipe transition needs to have has exit time turned off, and it needs to have three conditions in fact. The first one being if that attack integer is greater than 0, and also if that attack is less than 51. Okay, so if it's a number between 1 and 50 and if crawling is true. And we want to do exactly the same thing now for the other transition into the right swipe, but of course change the attack range from 50 to 100. So once again, I'll create 3 conditions. I'll turn off the has exit time, and we'll say if attack is greater than 50. Actually, we don't need that second one, do we? Because we don't have to worry if it's less than 100. As long as it's greater than 50, this needs to be activated. And of course, we'll set crawling to true as well. There are actually 2 conditions when we should transition back into the empty state from any of our attack animations, be they crawling animations or non-crawling animations. That's when the attack is over, when it's played out. So we'll create that transition now and say the transition condition is simply that the exit time has been reached. And we'll do that for our left swipe as well. Once again, this time don't click has exit time. But we're also going to create another transition back for each of these states, which is simply when has exit time is off and attack equals 0. So basically, if we're in the middle of the attack and then the attack is over, we don't wait for the attack animation to play out. We transition straight back into whatever animation is playing on the base layer, which is probably one of the locomotion states. So we'll set that transition up as well for our left swipe as well. So we already have the transition that says has exit time is reached. But if before exit time is reached, the attack is cancelled and that attack integer is set to 0, well, then we also bail from the animation then as well. So let me just check those. Oh, I've done it wrong there. That's supposed to be attack equals 0, not attack doesn't equal 0. Okay. So if I play this now, it won't do any damage because we haven't actually set up any animation curves yet for our damage triggers on these animations. We'll do that later. But for now, we just want to see what happens and whether the thing does indeed come up and try to attack us from a crawling position. And there you go, she's hitting me. She's having a good old attack at me. So that kind of looks like it's working okay. And you might feel perfectly fine going with that. But if you study that, you'll notice that her hands are actually passing through the floor slightly. And if I call up the scene view, you might be able to see this a little bit better. There you go. Can you see her hands going through the floor? Which is really weird because they don't do that in the actual animation. So what on earth is happening here? So to understand this phenomenon, let us double click on one of our attack animations, such as this one here, attack 1. And you'll notice that when we play the animation, it's a really cool animation, but notice that the zombie is stood still while this attack is launched. And this is often the case for most of our attack animations. Now, although this looks really cool, we also found that when we allowed the attack animation to control the entire skeletal rig in this way, it became really easy for the player to avoid being hit by the zombie. Because as soon as the zombie ran up to the player and launched an attack animation, the feat would also stop. All the player has to do is literally just step back a foot and the zombie will miss it. So what we decided to do instead is say we always want our zombie running into the player even when it's attacking. And we did this by using an upper body mask on our attack layer. So if I click on the little cog that brings up the attack layer settings, you can see we have assigned it the upper body mask. And if I select that in the inspector and unfold the humanoid dropout, you can see that all of the animations on this layer will only affect the upper body, the bits that are highlighted in green here in the graphical representation of the avatar. And like I said, this is exactly what we wanted for our regular attack animation, so that whatever animation we play on the base layer, if a running animation is being played, those legs will still be running even when the attack animation is overriding the upper half of the zombie's torso. So it means we have the best of both worlds, right? We have the upper half attacking us, but while this is happening, we keep the zombie running into the player's collider to keep it continually as close to the player as possible. This works fine for our standard animations. However, when we use this upper body mask on the crawling animations, especially the crawling attack animation that we are using, we get this problem where the hands are going through the floor. But why is this? Because if I open up the left swipe animation, we can clearly see that the hands are not going through the floor on the original animation. But what's probably happening here is that by using that mask, we are masking off some bone rotation in the lower body, and it's not allowing the upper torso to rotate up quite as much as it needs to be, which means obviously when the hands come down, they're slightly lower than they should be, and we're seeing them pass through the floor. So what we're going to need to do, folks, is we're going to need to say, well, this attack layer is fine for when we wish to perform attacks that only affect the upper torso. So where are we going to put these crawling attacks? Well, we could, of course, create another attack layer which didn't have a mask task on it, but that's just superfluous. At the end of the day, these animations need total control over the entire hierarchy of the skeleton, so that's exactly the sort of animation that should be on the base layer. So I'm going to delete these animations completely and undo all of that work, and what we're going to do is we're going to put them on the base layer instead. Now this is slightly painful when we do this, because the really nice thing about having this attack layer is we can just go in and out of the empty state without having to worry about what's happening on the base layer. For example, is it in an idle state, is it in a slow crawl, is it in a fast crawl? Because we are now going to put the swiping and the biting animations on the base layer, that means that when the attack is over and we come back out of an attack animation, we also need to have multiple transitions with conditions to figure out which one of the locomotion states we need to actually go to. So it just means we have a lot more wires, much like this up here, which isn't as clean to look at as our nice attack layer. But hey, that's the cost of doing business. So I'm going to drill down into my animations folder, my Game Institute folder, my attack folder. I'm going to open up the crawl attack FBX. I'm going to drag over the left swipe. I'm going to drag over the right swipe. And I'm going to drag over the biting animation. I'm going to put them sort of lined up pretty close together, just to the right of our zombie crawling locomotion states. Now fortunately, I don't have to worry about connecting left swipe, right swipe or biting with the idle state, because the idle state is a transition that will transition out of it as soon as we are no longer in the idle state in the underlying zombie state machine. So if our zombie is attacking, then clearly it's not in the idle state anymore, so it's going to be in one of these states instead. So we only have to worry really about transitioning from each of our locomotion states into each of our attack states and then back again. So let's start with, I don't know, should we start with the slow crawl? Why not? So we'll do a transition from slow crawl to left swipe, a transition from slow crawl to right swipe, and a transition from slow crawl to biting. We'll then do a transition from left swipe to slow crawl, a transition from right swipe to slow crawl, and a transition from biting to slow crawl. And obviously we're going to have to do all of this again in a minute for the fast crawl as well. And there's also a few transitions back into slow crawl that we're going to have to deal with in a minute as well. So let's talk about what we're going to do with the attack parameter and how we're going to distribute the probabilities of each of these attacks being selected. So remember, our attack integer will generate a number between 1 and 100. We want biting to be much more rare than just a general swipe. So what we will say is we will say an integer range of between 1 and 40 is a left swipe, 40 and 80 is a right swipe, and 80 and 100 is the biting animation. So let's start first with the transition from our slow crawl into our left swipe. Well, first of all, we want to turn off has exit time because we don't want to have to wait for the slow crawl animation to reach the end of the animation cycle before the swipe happens, or otherwise by the time the swipe happens, the player may have moved away. So we want the attack to be instant. So what we want to do is we want to have two conditions here. The first one is that our attack integer is greater than 0, so we know we're in the middle of an attack, and also that our attack integer is smaller than 41. So in other words, if it's an integer between 1 and 40, which is the range of probability we said we would assign to the left swipe. And that's the only conditions we need. Now you might be thinking, well, don't we also need to set the condition that crawling equals true? Well, you could do, and it wouldn't hurt, but I don't think it's necessary. You see, we can't ever get to the slow crawl unless we are in a crawling state, because this transition can only happen if crawling is true, and we can only get to zombie slow crawl through crawling idle, and crawling idle can only be gotten to by this transition here where crawling also has to be true. And of course we know that in our system you can never be a crawling zombie and then not be a crawling zombie anymore. Once you're a crawling zombie, you've got leg damage and you're staying damaged. So let's now work on the transition from zombie slow crawl to zombie right swipe. Once again, we turn off has exit time. We set two conditions for this transition, and you probably know what they are, that attack is greater than 40 and attack is less than 81. Remember, we said that the probability of the right swipe being selected is when that integer is in the 40 to 80 range. Finally, we'll do the transition from zombie slow crawl into biting. Once again, we turn off has exit time, and the conditions are simply that attack is greater than 80. In other words, 81 to 100. So we've set up all of the transitions now to go from zombie slow crawl into our three animations. Now we have to set the transitions that go back into the slow crawl. And these are slightly trickier, or at least trickier than they were when we had them on the attack layer. Because not only do we have to have two transitions back, for example, when the exit time is reached, in the case of left swipe and right swipe, and also if the attack should be aborted, such as if we find that attack has been set to 0. But what we also have to do now is determine what the speed is and choose the correct locomotion state to go back to, because when left swipe is over, we need to know whether we need to go back to the fast crawl or the slow crawl. So we have one transition from left swipe back to zombie crawl already, so let's set that one up. And we'll say that this is the transition that is activated when the left swipe reaches the end of its timeline, because remember, left swipe and right swipe, unlike the biting animation, are not looping animations. So when the exit time is reached, we want to go back to wherever it needs to go back to. Now on the attack layer, this transition would already be complete. It was simply, if exit time is reached, go back to the empty state. But now what we need to say, if the exit time has been reached, is the speed such that we need to go back to the slow crawl? So we're going to add a condition there that says if speed is less than 2. Remember, for our speeds, speed 1 is a walk, speed 2 is a jog, and speed 3 is a sprint. And in the case of our crawling locomotion, we'll say speed 1 is a slow crawl, and anything above speed 1 is a fast crawl. So if the speed is less than 2 and the exit time has been reached, in other words, the animation is finished playing, go back to the slow crawl. But we also need another transition here back to the slow crawl for if the attack should be aborted when it's halfway through. So for this transition, we'll say if exit time hasn't been reached, but if the attack integer equals 0, which is what will happen if we cancel the attack. And of course, attacks can be cancelled when the animation is halfway through for very simple reasons, such as if the player moves away such that the zombie is no longer in the melee trigger of the player. But of course, we can't just say if attack equals 0, go back to the zombie crawl slow, because we may have to go back to the zombie crawl fast. So we also need to know what the speed is. So once again, we say if the attack has been cancelled and the speed is less than 2, then we go back to the zombie slow crawl state. So let's now set the transitions from the right swipe into the slow crawl. So once again, the first transition is going to be when exit time has been reached and when speed is less than 2. Because if it was greater than 1, then it means we need to go to the fast crawl instead. Well, then that's our first transition done, and then we'll do a second transition which doesn't have has exit time ticked, but has when attack equals 0, in other words, the attack has been aborted, and when speed is less than 2. Okie dokie, that's that done. And finally, we need to set the transition back from our biting animation back into the slow crawl as well. Now, our biting animation is a looping animation, so it doesn't have an exit time like our left swipe and our right swipe animations. We simply want to stay biting the player until the player steps away from the zombie or dies, in which case the attack is cancelled and that attack integer will be 0. So we turn off has exit time and we simply have the one transition that says if attack equals 0 and if speed is less than 2. Okay, so that's our slow crawl done, I think. Now it's time to do all that again, but this time for the zombie fast crawl. So we'll start with the transitions out of the fast crawl into the various attack states, like so. I'm trying to put these in a way that makes them a little bit easier to see the wires. It's becoming a mess there, isn't it? Oh joy. Okay, so we go from zombie crawl fast into the left swipe if, and we turn off has exit time, attack is greater than 0 and attack is less than 41. We go from the fast crawl into the right swipe, once again turning off has exit time, adding the two conditions if attack is greater than 40 and if attack is less than 81. And we go from the fast crawl into the biting, once again turning off has exit time if attack is greater than 80. So that's just the same probability distribution that we had when we came from the zombie slow crawl as well, okay? Just 40%, 40%, 20%, or at least roughly. Okay, so let's work on the transitions now from left swipe back to the zombie fast crawl. So I'll make the transition wire and select it. And the first transition is going to be when we've reached the end of the animation. So we leave has exit time clicked. And all we have to do then is just check what the speed is. And if the speed is larger than 1, then we go to the fast crawl. Otherwise, as we've seen, the other transition will be activated, which will send us to the slow crawl. So the only condition here, remember has exit time is clicked here, is if speed is greater than 1. But we also need another transition to go back into the fast crawl if the attack is aborted when it's midway through. So for that transition, we will turn off has exit time, and there'll be two conditions. It will be when attack equals 0. In other words, the attack has been aborted because the player may have stepped away from the zombie, and when speed is greater than 1. Okay, we're getting there slowly but surely. Okay, now we do the transition from right swipe back to the zombie fast crawl. Once again, has exit time is ticked and speed is greater than 1. And of course the second transition from right swipe back into the zombie fast crawl is when the attack is interrupted for whatever reason. So just as with the other transitions of a similar type, we turn off has exit time. We have two conditions: when attack equals 0 and when speed is greater than 1. Phew, and now we've got one more to do, the biting animation. So let's make the transition back into zombie crawl fast from the biting animation. And we only have one transition here back into the fast crawl, just like we do from the biting back into the slow crawl, because there is no such thing as the exit time in our biting animation, because it's a looping animation that will loop endlessly until attack is set to 0. So we turn off has exit time, and we simply have two conditions that say if attack equals 0, then it means the attack has been aborted, and if speed is greater than 1, then we go back to the fast crawl. Now I did that pretty quick, so you can always rewind back and pause the video to see what I'm doing. But I'm going to press play now, and the chances of this working, I don't know, pretty remote I would imagine. I've probably left something unticked somewhere. Okay, so let's see him come up to us and see if he attacks us. So she's gathering speed. There you go, and she's doing like a biting animation there. So let's see if she comes up and does a swipe animation. Just want to check the probabilities are working. Yep. Doing left swipes and right swipes and bites. Kind of moving around a little bit. I think we probably have to use root rotation on those as well, possibly. I'm not sure. Yeah, maybe we do. They're sliding around a little bit, and I don't know if I like that. I also want to turn down the probability of the biting as well, because that is happening way too much. Oh, no wonder I didn't put any root motion configurators on the attack animations, which we have to do now, of course, because these things are controlling the entire skeletal hierarchy. So I'll just try root position first of all, and not root rotation, because we want our underlying zombie state machine to still be able to rotate our zombie to keep it facing the direction of the player. And one more root motion configurator on there. I'll set that to 1 as well. Let's press play and see if we stop that skating around on the floor when the zombie comes up to us. I'm guessing it will. We want to see her rotate, but we don't want to see her actually moving around, do we? Oh, there you go. That looks much better. Yeah, there you go. She stopped moving around me now. She was orbiting me like a planet. Yeah, actually, I think I'm fairly happy with that. So that's our crawling locomotion done. Of course, you will have noticed that while Zombie Jill was swiping at our feet, we were seeing no blood happen on the screen to indicate that we were being damaged. And of course we weren't being damaged because we haven't yet added any animation curves to our left swipe, right swipe and biting animations that indicate the parts in the animation where damage should be applied. So just to remind you, if I go to our attack layer and say call up the attack 1 animation, you will remember that we have some curves on these animations. Like this is a right-handed animation, so you can see we've got this curve on a right hand that goes between 0 and 1, and where it's 1 it indicates the section of the animation where damage should be getting applied. And you can see that the name of the curve, in this case right hand, is married up with a parameter with the same name in our animator, so that the value of that curve is constantly being sent into the animator, and then when we do register that one of Jill's damage triggers has hit our player, we can check the corresponding parameter in the animator, and if it's 1 then damage is applied, but if it's 0 then it means we've basically just brushed up against the trigger, and therefore that particular part of the body shouldn't be causing damage at that particular point in time. So we need to add the right hand and the left hand curve to our 2 swipe animations, and we also need to add the mouth curve to that biting animation. So let's select our animations and do that now. So I'm going to start with the left swipe, which is obviously going to have a curve on it with the name left hand. So I scroll down and I click the little plus sign underneath the curves drop down, and I call this left hand. Capitalization is important at this point. And then what I'm going to do is I'm going to seek along to the point in the animation where I think the hand should be doing damage, and I think it's about here, right there. I'm going to put a keyframe. Then I'm just going to come back one frame and add another keyframe there. And then I'm going to seek through again. I think probably the hand should stop doing damage about there. So I'll add one more keyframe, skip forward another frame, add another keyframe, and then what I'll do, those two keyframes in the middle, I will set their values to 1. And if you don't know what I'm doing here, it basically means you skipped a lesson a while ago where I described how these curves are used to apply damage. Okay, so we've got the curve on the left swipe. Let's press apply. Let's now go up, select the right swipe animation, and this time add another curve, but this time it's going to be called right hand, like so. And once again, we'll just seek along. As it starts coming forward, we'll start to make it hostile, so I'll add one keyframe there. I'm going to press the right cursor key to move it on a frame, add another keyframe there, then holding the right cursor key, I'm just going to seek it along a little bit more to about there, add a keyframe, skip along right along the timeline by just one more frame, add another keyframe there, and then I'm going to move back to those two central keyframes and set their values to 1. Like so, press apply, and now all we have to do is add the mouth curve to the biting animation. So once again, with the biting clip selected, we pull down the curves drop down, we click the little plus sign to add a curve, and we create a curve called mouth. Actually, this is pretty easy. This just needs to be 1 all of the time. So we'll go right back to the very beginning, the very first keyframe, which is automatically there. We'll set that to 1, and then we'll skip along to the end, the very last keyframe, which once again is always there, not something we have to add, and we'll set that to 1 as well. And then we'll click apply, and we just have a constant curve there of 1 for our biting animation. So if I press play now, when the zombie attacks us in the crawling state, I'm hoping we are going to see us get some damage. Come on, Jill, do your thing. Dun, 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 dun. Yeah, there you go. Look at that. Oh, yeah. Oh, that's cool. So that's all working. So we now have our attack system for crawling completely done now. Okay then, so we just have one more problem to address before we finish up this lesson. And I saw this problem at the end of the last lesson, and it is a problem with our reanimation system. It's a really simple fix, and I don't know whether you saw this little glitch during the reanimation. And it really only shows up prominently when we are reanimating from a ragdoll into a crawling zombie. So what I'm going to do is I'm going to run the game, I'm going to go and find Jill, I'm going to shoot her in the back like a coward so she ragdolls. And then I want you to study her animation as she blends from a ragdoll back up into a crawling zombie. And what you'll notice is just as she gets to the end of the reanimation procedure, just as she transitions into a fully animated zombie, you will notice a glitch in her position. It's quite subtle, but you'll notice it's almost like her game object is shunted up a couple of inches. Well, in fact, you'll see in a minute that's exactly what the problem is. But for now, I just want you to look at it and see what's going on. So I'm going to maximize the game view. I'm going to go and shoot her in the back. There you go, I've shot her in the back. Now watch her. Did you see that little glitch? I said it's quite subtle. You see, it's a little pop. Now you probably think I'm being fussy, but it drives me crazy. And actually, the good thing about it is it did actually indicate a problem, something I'd overlooked in our late update function in our zombie state machine when we're doing that bone blending. So what's actually happening when I spent ages trying to debug this, because I thought it was a problem with my transitions or my animation offsets and things like that. But what it is, we're not correctly calculating the final position of our game object, factoring in all the information that we need to factor in. Now, if I call up our late update function in our AI zombie state machine, remember this is the function that is called, and this is the code that gets executed when we are in the ragdoll to anim blend state. You'll remember that we cast array and we find the highest Y position, and then what we do is we sample the nav mesh, and if we sample the nav mesh we set that new position as our transforms position, or if we weren't able to sample the position we just use the new root position as our transform position. That's just a little bit of fail-safe there in case for whatever reason we can't find a position on the nav mesh. These positions are wrong because they do not factor in that our nav agent may have been assigned a base offset. So if I go back to the editor for just a moment and I select Zombie Jill's AI entity game object, you can see that in my nav mesh agent, I have a base offset of 0.07. Now the base offset is just a way of offsetting the game object itself from the bottom of the nav agent cylinder. And this is useful because I was finding that without any base offset, Zombie Jill's feet were slightly intersecting the ground. So it just allowed me to say, hey, I want you to just lift the mesh up a little bit so that her feet are on the ground when the nav agent thinks that it is on the nav mesh. So it's just a way of marrying those two things up so that they play nicely together. So of course, what's happening is when Zombie Jill is shot, she goes into a ragdoll. The nav agent is turned off, so this base offset is discarded, and she just falls onto the floor. Then what we do is we start blending from the ragdoll positions to where we think the game object needs to be. And to find where the game object needs to be, we simply move it to basically the hit position and find the surface under that hit position. But that position that we're blending to doesn't factor in the base offset. So just as we get to the end of the blending procedure, when we realize that it's time to transition to a fully animated character, we then turn on the nav agent and the animator. And at the point the nav mesh agent is turned on, we see this little pop as the nav mesh agent then pushes our character 0.07 meters into the air from the position that we'd blended to up to that point. So all we have to do is fetch the base offset from the nav mesh agent and factor that in to the new position. So that's really easy to do because base offset is a property of our nav mesh agent. So what we'll do in that section of code where we assign a position to the transform of our zombie, we'll just make sure that we add on to the Y component of its position the base offset of the nav mesh agent. So I think we can probably do something like this. We will say vector3 base offset equals vector3 0. So we'll start off with a vector where all components are 0, and then we'll say if, and assuming we have a valid reference to a nav agent, we will say base offset dot y equals nav agent dot base offset. Nice and easy. And then underneath where we actually assign the new nav mesh position or the new root position, we just can add our base offset vector to that, plus base offset plus base offset. And the only reason I do it this way by creating the 0 vector first is for whatever reason, if we don't have a valid reference to a nav agent, then we're not going to be trying to do anything that's accessing a null reference. So I'm going to save that off. I'm going to press play now, once my script is compiled of course, just check I haven't got any errors. And we're going to shoot Zombie Jill and we're going to see if that little glitch has gone now. Oops. I set a breakpoint by accident. Okay. Let's shoot her. And we should see now that there is no glitch. Perfect. As smooth as a baby's bottom. Look at that. No glitch at all. So problem solved. Oh damn, I thought we were done, but I've just remembered there's a whole thing we haven't done yet, and that is we haven't put any logic in place to handle when a crawling zombie comes across a dead body and wants to feed on it. So we're going to have to do that now before we end the lesson, or otherwise we're going to have some of the crawling behavior not implemented by the end of this lesson, and there's no way I'm going to let that happen. So just to prove what's going to happen at the moment if we don't do anything, let's make sure that Jill's lower body damage is set up to 95, so she starts off as a crawling zombie, and I'm going to set her satisfaction down to about 0.1 so that when she finally comes round, she's going to see the dead body and she's going to start crawling towards it. Now, if you've wondered why she hasn't been crawling towards it before, it's because I had our cop zombie here turned off. So I've just turned her back on again, and you'll see what happens when she comes around the corner here. She'll pick up speed once she sees the target. She'll head towards it, but when she gets to the target, she won't know what to do. She doesn't have an animation to play to feed from a crawling state. So I'm going to pause the video until she comes around the corner. Okay, so here she comes, and in a minute she should see the dead body, she should realise that she's hungry, and she should pick up speed and start crawling towards the target. There she goes, she's picked up speed, she's coming, it all looks very convincing, but when she gets there she'll have no idea what to do next, and she'll just start crawling around on top of the body, like that. So the reason why this is, of course, is if I call up Zombie Jill's animator and select a cinematic layer, you can see that on the cinematic layer attached to the empty state, we have the zombie eating intro, the animation called feeding state, which is going to be playing for the entire time that she is feeding. That's this animation here, where she's bent down feeding. And then we have the outro out of feeding, where she stands back up again. And of course the transition from empty state into the zombie eating intro is that feeding is true and crawling is false. And of course that has to be the case because these animations just do not fit a crawling zombie at all, because the crawling zombie would crawl up to the dead body and then it would have to climb up onto its feet just to fall down onto its knees again, and that makes no sense. So what we're going to need to do is create some similar logic here for when the zombie is in a crawling state. Now we don't actually have any animations dedicated to the zombie feeding in the crawling state, but I think we can make some from the animations that we already have. So what I'm going to do is drill down into my animations folder, my Game Institute folder, and my attack folder, and I'm going to select that crawl attack FBX that we imported in this lesson, and I'm going to select the all anims clip because this clip allows us to see all of the animations. And you can see that one of the things that we have that we haven't used so far is we have this little bit at the beginning of the animation where she brings the hand up to her mouth, which we could use as the start process of her going into a feeding state. And then when she's in the feeding state, we will have her just using that biting animation that we use when she's attacking the player. And then when she has a full belly and it's time for her to transition back into a crawling locomotion again, what we'll do is, actually we can't use that because this animation goes straight into a swipe. But what we can do is we can take this animation here where she brings the hand up to her mouth and we can play it backwards. So her hand goes down to the floor before she transitions into a standard crawling zombie again and goes about her business. So in order to do that, we need to chop out this little bit here where the hand leaves the floor and comes up to her mouth. So we'll click the plus sign underneath the animations clip list to add a brand new animation clip, which is called animation by default. We'll click the clamp range button to get rid of that little import problem. And then I'm going to call this crawl feeding intro. And then what I'm going to do is I'm going to move the marker back to roughly where, about there I think, so about frame 16, yeah, and then we can blend this animation then into our biting animation, and I'm just going to move the start marker forward to about frame 4. So this is what's going to play, just a little hand coming up to her mouth like that, then it will blend into our biting animation. And like we did with the other animations that were in this FBX file, I'm going to bake the root position Y into the pose, okay? And I'm going to click apply. And if we look at our crawl attack FBX now in the project view, we can see that not only do we have this biting animation that we created earlier, but we also have the crawl feeding intro as well. So what I'm going to do is I'm going to take that crawl feeding intro animation, I'm going to drop it into the cinematic layer of ZombieJill's animator. I'm then going to do exactly the same thing again. Okay, I'm going to make a duplicate by dragging in another copy of the crawl feeding intro, and I'm going to select that second copy and I'm going to rename it crawl feeding outro. And what I'm also going to do is I'm going to set the speed to -1 so that it's going to play backwards. And then finally I'm going to go back into my attack folder again and I'm going to copy over the biting animation, which is the animation we use for our biting attack, and I'm going to rename this crawl feeding state. Okay, so all we have to do now is hook up the transitions, much like we did above with our non-crawling feeding state. But instead of the transition saying crawling equals false, we want crawling to equal true. So we'll make a transition from empty state into the crawl feeding intro. We'll turn has exit time off, and the condition will be when feeding equals true and when crawling equals true. Then we will create a transition from that little animation where the hand comes up to the mouth into the looping feeding animation. Because remember, this biting animation here, actually I thought I renamed that. I obviously forgot to press enter again. I do that all the time. So I'm going to rename it now and call it crawl feeding state. And remember this time to press return. And the transition into the crawl feeding state animation, if I remember rightly, if I look at the one above, it's just has exit time. So we've done it. That transition is alright as it is. We just want it to go into this after the crawl feeding intro is played out. And then we want it to stay in the crawl feeding state until it's time to come out of that state. And it comes out of that state simply when feeding no longer equals true. So when feeding is false. And then finally we're going to come out of the crawling feeding outro when the exit time is reached, so we get it to play to the end of its sequence. So I'm going to select that transition, and all it has is has exit time ticked and it has no conditions. So you're probably thinking, hey, this is really cool, we're all done. Well, unfortunately, there are some problems with our feeding state code which we're going to have to address, but I'll talk to you a little bit about that in a moment. So when I press play now, I'm going to pause the video again until Zombie Jill comes around, and I'm also going to select her AI entity so that in the inspector I want you to look at when she goes into the feeding state at her satisfaction. You're going to notice it's not going to go up, and it should do because we know when she's feeding her satisfaction should be replenishing. We can see at the moment it's going down as she's crawling around the level. Okay, so here she comes. Let's just check the animation works at least into the feeding state, but she'll never leave the feeding state because her stomach will never fill up. And we'll explain why that is in a minute. Okay, so forget the fact that she stopped short because we're going to fix that in a minute. You can see she did actually go in correctly into the feeding state. And if we look at our animator, we can see that she's now in the crawl feeding state. But if I select her AI entity, look at that satisfaction value in her inspector, it's at 0 and it's not going up. Why is that? Well, in order to understand why we've got this problem, we need to take a look inside the feeding state, because the feeding state does something a little bit specific to the names of the animations on this layer. So I'm going to open up the zombie feeding state, and you'll notice that one of the things we do is we get the hash of the feeding state, which remember is this feeding state here, the animation that is looping when the zombie is feeding, not in a crawling state. And you can see that later on in the update function, we say to the animator, please give us the hash of the animation that is currently playing on the cinematic layer. And then we compare that against our feeding state hash. So really what we're doing is we're saying to the animator what state is playing, and if it is a state that is called feeding state, then that's when we add the satisfaction onto the zombie and we do all the blood particles. The problem is we now have a second feeding state on this cinematic layer called crawling feeding state. So you're probably thinking, well, why don't we rename crawl feeding state and just call that feeding state as well? So both of them will cause a match in this conditional here, but unfortunately you cannot have two animation states on the same layer, and remember these are both on the cinematic layer with the same name and therefore the same hash. So what we're going to need to do instead is we're going to need to add a second hash to our AI zombie feeding state so that it can check that it's not the normal feeding state or the crawling feeding state. So I'm going to go back to my AI zombie feeding 1 state, and right at the top where we create the feeding state hash, I'm going to create another private int. I'm going to call this crawl eating state hash. I'm going to set the value of that to animator string to hash, and we called it crawl feeding state, didn't we? Like so. So now we have that hash, we can go down to the update function and we can check both of those states. So to make that a little bit more efficient, rather than each time fetching the current animation state info, what we will do instead is we will say int current hash equals zombie state machine animator get current animator state info, and we pass in the eating layer index, which is cached in the onStateEnter function, and we get the short name hash, which is an integer. So now we know the hash of the state that is currently playing. We can make this line a little bit shorter and say if current hash equals the eating state hash, oops, let me remove that underscore, or if current hash equals the crawl eating state hash, well then we should see our satisfaction go up again and everything should work just fine. So we better test that before we go on, hadn't we? So I'm going to press play again, and just like I did before, I'm going to set the camera down by the dead body. I'm going to pause the video until Jill comes around, and I'm also going to select the AI entity object so we can just check that her satisfaction does start climbing up when she starts feeding on this dead body. Okay then, so here she comes with all of her colliders and nav agent bounding volumes. So she should start picking up speed now, and I know it's hard to see with all of these colliders and bounding volumes on it, but we should be able to make out whether it's working. So we should see a stop when she gets within range, and then she brings her hand up to her mouth. If you look now at the inspector, you can see the satisfaction is climbing up, and she's just going to stay there eating until she gets above a certain threshold. So let me just drag that slider up to give her a bit of a helping hand, so we're not sat here for ages. And there you go. After she finished feeding, her hand went back down, she transitioned into the crawling state, and of course what she's doing now is she's off to go and visit that first waypoint, which she never got to because she got distracted when she saw the dead body. So, okay, not too bad, but the problem that we have at the moment, and I'm just going to run this again, but this time I'm not going to select Jill as she approaches the dead body so that we can see that she stops very short of the actual dead body when she starts feeding. And we saw this a little bit with even when she isn't in a crawling state. It was kind of a bit hit or miss where the zombie ended up, because of course if we select our cop zombie here, we can see that it has this little trigger here, and when this trigger enters kind of Jill's trigger, that causes her to drop down. But Jill's trigger is quite big, so we need to make it quite big so she doesn't overshoot it. But often when she falls down onto the body to feed, she isn't actually making contact with the body, and you're going to see that here now, hopefully. Last time it wasn't too bad, but a couple of times I've tried this and it stops way short of where it should be. There you go. So I mean, that looks, let's be honest, that looks kind of crap, right? We want the mouth to be kind of here. So we didn't do this before, but now we know a lot more about how the animator works, and we know about all of the human body parts and the bones that we can get access to via the animator. So we're going to fix this now, and of course this is going to be a fix not just for our crawling feeding state, but it's also going to make our non-crawling feeding state much more accurate as well. And the fix is really, really simple. All we have to do is in our feeding state, every update, we just need to create the vector from where Zombie Jill's head is to where the actual target of the feeding source is, which is the neck of this character. And then we just have to move the zombie over time so that the head is at the position of the source of the food. And we can do that really easily now because we know that we can say to the animator, please give me the transform and therefore the position of the head of this character. So we did something very similar actually when we were in our late update function, when we were moving the game object along a vector to the hip position of the ragdoll. We're going to do a very similar thing here. So once again, in the zombie feeding state, I'm going to scroll down to the very bottom of the update function. Underneath that little section where it says, if not using root rotation, then we rotate the zombie to keep looking at the food source. But then underneath that, I'm going to put some code that is going to move our zombie's transform along a vector towards the actual target. So to do that, we'll create a vector 3 and we'll call this head to target. And this is simply going to be the zombie state machine's target position, which of course in the case where the target is the food source, it's going to be that little sphere trigger that we placed on the dead body's neck. And we're going to subtract from that our head position. Well, we know how to get the head position now. We just need to get the zombie state machine's animator, and we need to use its get bone transform function. And the bone we want is human body bones. I've spelled it wrong. I've said humand. Human body bones dot head. That will return the transform, and of course what we want is the position. So now that we have that vector to move the zombie along, we need to get the transform of our zombie. So we say zombie state machine dot transform dot position equals, and we'll do a vector 3 lerp over time, and we want to lerp from the current position to the current position plus that vector. So plus head to target. So what we're saying is we've created a vector from the head to the target. We're now going to move our game object along that vector over time by lerping between the current position and the position that we're trying to get to, and we'll just use time.delta time. I don't think we need any control over this. We just want it to kind of move slowly and slide into the correct position. And then I'm going to save that off. And what we should see now, providing I don't get any errors, is when that zombie comes round, we should see a pretty exact feeding ritual, both in the crawling zombie and in a non-crawling zombie. So I'm going to pause the video and wait for Zombie Jill to get somewhere a lot more interesting. Okay, so here she comes. There she goes. Come on, Jill, don't let me down. I want to see that head really get into the neck, so it really looks like you're eating that cop vampire style. So you go, it stops there. Yeah, there you go. We kind of move her into position, which I think's great because, I mean, you could make the move even quicker, but I think that's fine because for the most part, you're not really going to see the zombie go into that position. But when you come around the corner and the zombie's feeding, it looks like it is really feeding from the correct place. And just to check that this also works when our zombie is not a crawling zombie, I'm going to select our AI entity game object. I'm going to move lower body damage down to 0 so she's no longer a crawling zombie. I'm going to press play again and I'm going to see this play out again, and you'll see that it's exact again. I'm going to pause the video until Zombie Jill comes round the corner. Okay, so here comes Zombie Jill. She's just walking around doing her thing. She's going to see the target. She's seen it. Now she's running. And let's hope that head ends up right on it. So you can see at that point, she initially overshot it. And had we not added that code, her head probably would have been somewhere over by this hand, or even overshooting the body altogether. But now you can see it really does look like she is right in there with her head buried right in the other zombie's head. So that is brilliant. I'm much more happy with that. And that is quite an improvement to our feeding state. So that's it for this lesson. Let's be honest, been a pretty tough lesson, but there's a lot of things we've got done. Not only have we implemented crawling locomotion properly, we've put crawling attacking in, and we've really made our feeding ritual, be it for a crawling zombie or a non-crawling zombie, much more robust. We also fixed a few problems. We sorted out a glitch in the reanimation procedure. We added back our damage triggers, which we didn't even know were missing, that the Ragdoll Wizard had removed, and a few other things as well. Okay, so thanks for listening, guys. In the next lesson, I think what we're going to be doing is we're going to be adding 2 new layers to the animator so that we can see damage play out on our zombie. So if the zombie has some leg damage, it may start limping, or if it has some upper body damage, its arm may be sort of hanging down limp. So thanks for staying with me, guys. I will see you in the next video. Bye bye now.